we're going to be doing rational expressions and functions, a special topic which is complex fractions. So let's first start out by trying to decide what a complex fraction is. A complex fraction is a rational expression where you have both rational expressions in the numerator as well as rational expressions in the denominator. So for example, we might have the expression 5 over x minus 5 over y. So it's complex because we have, in this particular case, we have two rational expressions in the numerator, two rational expressions in the denominator. The goal is to try to change this expression that is given here into one fraction, one rational expression in the numerator and another rational expression in the denominator, so that then we can say, well, we have one rational expression divided by another one, and so we can invert and multiply and then simplify. So that's the goal, to do this. We have a couple methods that we're going to use to accomplish this goal, and so method 1 tells us that what we're going to do is to find a lowest common denominator for the numerator, and then we're going to do the same thing and find a lowest common denominator for the denominator. So let's do that part first. X plus 5 over y, and that's going to be divided by 5 over x minus 5 over y. Now, we want to get in this particular case, since they're simple denominators, if we multiply both of them, we will be fine. So what we'll do then is for 5x, we're going to change that into a number that has a denominator of xy. And so what we need to do is multiply the denominator by y and the numerator by y. And so we have, for our first term, we have 5y over xy. Notice that if I cancel the y's, I end up with a 5x, which I started with. For the second expression in the numerator, we'll do the same, but this time we're going to multiply it by x over x, and so we have 5x over xy. The denominator is fairly simple in this case, the lowest common denominator, because we can just multiply the denominators that are given there. And we'll do the same as we did for the numerator. We need a y for this first denominator by y and the numerator by y. So now we have 5y. For the second expression, we'll multiply the denominator by x, since we don't have x's in the denominator. We'll do that the same to the numerator. Again, remember, we're multiplying by an expression, changing the number that we have. Now it's in this form of a over b divided by c over d. We have one fraction in the numerator divided by one fraction in So we'll have the rational expression in the numerator, which is 5y plus 5x divided by xy. The inverted denominator, which is xy divided by 5y minus 5x. And now it's a matter of multiplying fractions, and we've done that before. We will try to factor numerators, factor denominators, and cancel common factors. So from the first expression right here, we see that 5 is a common factor. So let's factor that out, and we're left with a quantity which is y. For the second factor, we start out with the xy, and for the second factor right here, we notice that we have a 5 that's common to both. We'll factor that out. We're left with y minus x inside the second factor. And at this point, we will go ahead and try to count common factor. The x is a common factor. The y is a common factor. And we're left with y plus x divided by y minus x. So in other words, we were able to write the expression 5 over x plus 5 over y divided by 5 over x minus 5 over y as the expression y plus x divided by y minus x, which is much easier to work with. Remember, once again, we cannot cancel the y's, we cannot cancel the x's, because we need factors to simplify. Fraction, with this particular complex fraction, and we were able to write a rational expression. Let's take another example. Suppose we have 5 over t minus 3 over 5 over t squared plus 3. Okay? The problem is no different than the one that we just did. 3 does not have a denominator, but of course we know that 3 is the same thing as 3 over 1. So you can consider the denominator for 3 over 1. So that doesn't pose any problems. And so let's do the same method of simplifying this expression as we did with the denominator, write one fraction over the other, and then invert the multiplier. Remember again that the goal of all of this is to have one rational expression in the numerator divided by another rational expression in the denominator. The denominator is simply going to be a t. 5 over t already has that denominator, so we simply write a 5. But the 3 over 1 doesn't have that denominator, so we'll multiply the second term in the numerator by t over t, and that gives us a minus 3t. Over 1, but our common denominator in this case is a t squared. The 5 over t squared already has that denominator, and so all does not have the t squared as a denominator, so we'll multiply the denominator by t squared, and that means the numerator by t squared as well. So we have 5 plus 3t squared divided by with one rational expression in the numerator over another rational expression in the denominator. And so now we can say we will simplify by dividing will now be multiplied by the inverted expression in the denominator, which is t squared over 5 plus 3t squared. Once again, we have now a product of two rational. Here, that 5 minus 3t does not have a common factor, nor does 5 plus 3t squared have a common factor. So our job is fairly simple. We'll cancel common factor to both of those. So finally we can say the expression then is equal to t times 5 minus 3t divided by 5 plus 3t squared in the denominator. Once again, we cannot cancel the t factors in the denominator because in the example of method 2,